When archaeologists recover wooden tools, structures and ship timbers from the cold north, they often encounter a contradiction. The wood should have decayed long ago. Instead, it is dense, darkened and hardened to a degree that resembles mineral rather than plant. This was not coincidence, and it was not the result of rare tree species alone. Northern builders developed a deliberate method that transformed ordinary softwood into something far more durable. This opening matters because once this process is understood, it becomes clear that medieval and early northern societies were actively engineering wood at the material level, not merely protecting it. Why northern builders learned to change wood instead of fighting decay. Softwoods dominated the northern forests. Pine, spruce and fir were abundant, workable and fast to shape, but they were vulnerable to rot when used carelessly. Northern builders did not attempt to replace softwood with scarce hardwoods. Instead, they altered softwood's internal behaviour. Their goal was not to coat wood, but to change how it interacted with water, oxygen and microorganisms. This shift in thinking is what made the technique so powerful. You know, it's fascinating how water saturation became the first step toward hardening wood. One of the most counterintuitive steps in the process was, in fact, prolonged water exposure. Softwood logs were deliberately submerged in cold streams, lakes, or bogs for months or even years. This leaching process removed sugars, resins, and sap compounds that, well, feed decay organisms. Cold water slowed bacterial activity while flushing nutrients out of the wood. Far from weakening it, this treatment stripped the wood of the very elements that, invite rot. So, to apply this technique today, untreated softwood beams, or posts, can actually be submerged in clean, cold water for extended periods, making sure they're fully saturated. The key, really, is duration and temperature. Warm, stagnant water tends to encourage decay, whereas cold, moving water preserves the structure while it gradually leaches out nutrients. Now, why did slow drying complete the transformation rather than just reversing it? Well, after saturation, the wood was never rushed straight into use. So it was dried slowly in shaded, ventilated conditions. You see, rapid drying would have reopened capillaries and caused cracking. That slow drying, well, it collapsed the internal moisture channels permanently. Once dried, the wood absorbed water far more slowly than untreated timber. It hadn't been sealed, mind you. Instead, it had been restructured. Modern builders can, replicate this by allowing water-treated wood to dry over months, elevated from the ground, protected from direct sun, and exposed to airflow. The patience required is, well, quite significant, but the result is materially different wood. It's not merely protected wood, you see. How cold climates amplified the effect. Northern climates played a critical role, Low temperatures slowed microbial action during both soaking and drying. Freeze-thaw cycles further compress cell walls, increasing density. Over time, this process darkened the wood and, well, hardened it internally. This is why, Bogwood, river-recovered beams and submerged piles often feel stone-like when cut centuries later. While modern climates may not replicate these conditions perfectly, cold season soaking and drying cycles still provide measurable benefits, especially in temperate regions. Why surface hardening locked in the gains? After drying, some northern builders applied controlled surface charring or repeated smoke exposure. This sealed outer fibres, closed remaining capillaries, and discouraged insects and fungi. Unlike modern coatings, this treatment did not trap moisture inside. It complemented the internal changes already achieved through soaking and drying. This step remains applicable today. Light charring or prolonged smoke exposure can significantly extend the lifespan of treated softwood used outdoors. Now, let's talk about how placement and design preserve the hardened wood. Well, pretty much indefinitely. The treated wood was never wasted by poor placement, you see. Posts were always elevated, and beams were protected from direct runoff. Structures were, carefully designed to shed water quickly. Even though the hardened wood resisted moisture, it was still allowed to dry fully after exposure. So all of this really completed the system. The transformation made wood resilient, and the design made that resilience, well, permanent. Now, the reason this technique disappeared isn't that it failed, not at all. It didn't vanish because it stopped working. Instead, it faded away because it demanded time, labour and patience. Qualities that just didn't fit with the relentless pace of industrial speed. Chemical treatments, on the other hand, promised much quicker results, even if, well, they only delivered shorter lifespans in the end. Knowledge that takes years to truly apply. It rarely survives in systems that are built around quarterly output. That's just the way it goes. So here's how you can actually apply this forgotten northern trick today. First, select untreated softwood. Then submerge it in cold, moving water for an extended period. After that, allow it to dry slowly in shaded, ventilated conditions. And, if exposure demands it, harden the surface as needed. Design structures that elevate wood and allow airflow. The result will not be indestructible, but it will outperform untreated modern lumber by orders of magnitude. Why this matters now more than ever? This northern technique did not turn wood into stone through magic. It did so by removing what biology needs to destroy it and reshaping its internal structure. It proves that durability can be engineered without chemicals, toxins, or disposable thinking. If you value knowledge proven by centuries rather than decades, subscribe to Ancient Know-How, share this guide with serious builders and history enthusiasts, and help bring back techniques that respected both material and time.